Okay, so now let's look at rounding. Let's say we have a question like this, which says round 0.257 to 2 decimal places. So the first thing we need to do is essentially to consider the second decimal place. So if we look at 0.257, so this 2 is the first decimal place, the 5 is the second decimal place, and the 7 is the third decimal place. But because the question is asking us to round to 2 decimal places, we are only concerned with the second decimal place, which is 5. Next thing we do is we look at the digit to the right of the number. So we look at this 7, which is to the right of 5. And if the number is 5 or more, we round up by 1. Or if the number is less than 5, we round down. And that essentially means that we keep the second decimal to the number 5 essentially the same if our number to the right of 5 is less than 5. So if we look at this 7 here, 7 is more than 5. So that means that we're going to have to round up. So that 5 at the end will turn into a 6, meaning we get an answer of 0.26. Okay, now we've got some more questions. So let's look at the first one together. Round 7.189 to 1 decimal place. So we look, the first decimal place is this one here. So that's the one that we are going to look at. Next thing we do is we look at the number to the right of the decimal place that we are looking at, which is going to be the 8, which is to the right of this one. We see if 8 is bigger than 5 or less than 5. Well, 8 is more than 5, so that means we are going to have to round up. So that 1 will turn into a 2. So our answer would be 7.2 to 1 decimal place. Next question here, round 4.678 to 2 decimal place. Same thing, this 7 is going to be the second decimal place here, so that's the one that we are concerned with. Then we look at the number that is to the right of that 7, which is this 8 here. 8 is bigger than 5, so that means we round up, meaning that this 7 at the end will turn into an 8. So we get an answer as 4.68 to 2 decimal place. Next one here is round 0.242 to 2 decimal place. So this 4 is the second decimal place, that's the one that we're concerned with. We look at the number to the right of the 4, which is the 2. As 2 is less than 5, that means we are going to round down, meaning that this 4 will stay as it is. So we get an answer of 0.24 to 2 decimal place. Now this one here, round 8.96 to 1 decimal place. So we look at our first decimal place, which is here, this 9. Look at the number next to it. which is 6. So this one's quite an interesting one here. 6 is more than 5, so that means we round up, meaning that the 9 is going to go up by 1. So because when we go up by 1 for this 9 here, this 9 will turn into the 0. And then that 1, we carry that 1 over here to the 8. So we get an answer of 9.0 to 1 decimal place. So essentially what we've done is we round up, this 9 will turn into a 0, and then we add onto the 1 to the number to the left of that first decimal place. And because we are putting it to 1 decimal place, it is very important to add that 9.0. If you just add 9, you're not putting it to 1 decimal place. So, yeah. Significant figures. To round to a number of significant figures, we follow the usual rules of rounding to a certain decimal place. So very similar to what we've been doing so far. However, the first significant of any number is the first digit, which is not 0. So what I'm saying is that if we had a number of 0.00496, and let's say I ask, okay, which one is the first decimal, the first significant figure, it's not going to be this 0, it's not going to be this 0, it's going to be the first non-zero, which is going to be 4. So 4 in this instance would be the first significant figure, 9 would be the second, and 6 would be the third. The second, third, fourth, and so on and so forth, significant figures follow on after the first if the next digits are zeros or not zeros. So again, if we have 0.0049602, so as we said, the 4 is going to be the first, the 9 is going to be the second significant figure, 6 is going to be the third, this 0 will be the fourth, and then the 2 would be the fifth significant figure. So follow, if there's a 0 next to the 4 or after the first significant figure, we count the zeros, but the first significant figure is not going to be a 0. So your first significant figure is going to be a non-zero. It's going to be a number greater than 0, essentially. Okay, now we've got some questions. So first one is round 0.002309 to 3 significant figures. So again, 0.002309, the 2 is the first significant figure, the 3 is the second, and the 0 is the third. Okay, similar to what we do with rounding, we look at the third significant figure, then we look at the number which is to the right, that is next to the significant figure that we are looking at. Then we see whether 9 or the number next to the significant figure is 5 or more, then we round up. If it's less than 5, we round down. Because 9 is more than 5, we round up. So this 0 will go up by 1. So we get an answer of 0.00231 to 3 significant figures. Let's look at this one here. Round 0.0287 to 2 significant figures. So 0.0287. So this 2 is our first significant figure and our 8 is our second. Similar thing, we look at the number to the right of the second significant figure, which is the 7. 7 is more than 5, so we are rounding up, meaning that this 8 will go up by 1, so we get an answer of 0.029 to 2 significant figures. Now we've got truncation, which is an alternative to rounding. When you truncate, you essentially cut off digits after the place value you are interested in. So for instance, let's say we have a number of 15.7932, and the question said for you to truncate to 1 decimal place. Similar thing that we do first with rounding is we look at the first decimal place here, which is 7. But what's different what is different from rounding with truncation is that when we round, we normally look at the number to the right of it, and then we sort of judge, okay, are we going to round up or are we going to round down? But with truncating, we don't really care what number is next to the decimal place that we are interested in. So this 9 can be a 3, a 2, or whatever. We don't really care. So we essentially cut off these digits here. We don't care. We sort of imagine that it's not there. So when we truncate this to 1 decimal place, we just get 15.7. So let's look at this one here. Truncate 0.0287 to 2 decimal places. So this 2 is the second decimal place. When we truncate, we cut off, so we don't care about the numbers to the right of it. So we get an answer of 0.02. Truncate 2.3678 to 3 decimal places. We look at the third decimal place, which is the 7, and we cut off all the numbers that are to the right next to it. So we get an answer of 2.367. Truncate 14.723 to 1 decimal place. Look at our first decimal place, which is a 7. Don't really care what number is next to it because we're essentially cutting it off. So we get an answer of 14.7. So let's look at this exam question. Calculate the area of the rectangle. So very important to underline and highlight key information in the question, which has a width of 89 centimeters. Okay, that must be important. And a length of 367 centimeters. Give your answer to 3 significant figures. So this question is nice to sort of visualize what we are looking at. Doesn't have to be perfect as I'm drawing right here. So length is 367 centimeters and our width is 89 centimeters. The formula for an area of a rectangle is area is equal to length times by width. So essentially 367 times by 89, which we get an answer of 32,000 663 centimeters squared. But that's not it, because it says that we must give our answer to 3 significant figures. So let's look. The 3 here is the first significant figure, the 2 is the second, and the 6 is the third. We look at the number to the right of this 6, which is the 6. As 6 is greater than 5, that means we have to round up, meaning that our 6 to the left is our third significant figure, is going to increase by 1. So we get an answer of 32,700 centimeters squared to 3 significant figures. Estimation. So to estimate a value for a calculation, first we need to round all the numbers, which I believe rounding to 1 significant figure works best, if not 2 sometimes. And then we use BIDMAS, so our brackets, indices, division, multiplication, addition and subtraction, to work out the estimated value. So let's look at this example here. Estimate the value of 11 times by 5.7 minus 23.4 all over 0.5. Show all of your workings. Okay, so let's round all of these numbers to 1 significant figure. So 11 to 1 significant figure. Yep, so the 1 to the left is our first significant figure. 1 is less than, well, the number next to the 1, which isn't 1, is less than 5, so we're rounding down, essentially. So to 1 significant figure, we get as 10. And 5.7 to 1 significant figure is 6. 23.4 to 1 significant figure is 20. And 0.54 to 1 significant figure is 0.5. Okay. Now we do our BIDMAS. So let's look at the top one first. So the numerator of the fraction. Got 10 times 6 minus 20. Using our BIDMAS up here. Multiplication is higher than subtraction, so we have to do 10 times 6 first, which is 60 before we subtract 20. So 60 subtract 20 is 40, so we do 40 divided by 0.5. Okay, 40 divided by 0.5. If this was a non-calculate, well, 40 divided by 0.5, if we know it, essentially that's going to be 80. But if we are not too sure, how I like to think about it is as 40 divide by 0.5, which is a half. And then we go over our rules for fraction when we divide fractions, which is our keep, flip, change. So keep the first fraction the same, flip the second fraction and change the sign. So you do 40 times by 2 over 1, so 40 times by 2, which is 80. So now, what if we have to estimate a square root of a number? So to estimate a square root of a number, we need to first find the two square numbers it lies between, and then decide which of the square numbers it is closer to, then use this to give an estimate. So let's look at this question here. Estimate the value of root 76 to 1 decimal place. So if we think of our square numbers, so we have 1, 4, and 9, 4 times 4, which is 16, 5 times 5, 25, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, which is 81, and then 10 times 10, which is 100. Okay, so root 76 we can see is between the squares numbers of 64 and 81. So root 64, root 76 is in the middle there, in between there. Then we have root 81. Root of 64 is 8 and root of 81 is 9. So first of all, we know that it's going to be 8 point something. But now we need to decide a given estimate of what value it's going to be. So then what we do is we look, okay, 76, is that closer to 81 or is that closer to 64? Well, let's see. To get from 76 to 81, we have to add 5. And then to get from 64 to 76, we have to add 12. Well, it looks like that this root 76 is closer to the 9 side than to the 8. So that means our estimate is going to be, as I said, closer to the 9 than the 8. So let's give us rough estimates. Let's say, because it's not in the middle, it's not snap bang in the middle, because as we can see here, let's say we get an answer of roughly maybe 8.7. Yeah, 8.7, which is correct. But you can also say 8.8 as well. So essentially it's just estimating, just figuring out, okay, which side is it closer to in terms of which of the square numbers it's closer to, and then from there we provide a sensible and appropriate estimate for this. So if you said 8.7 or 8.8, that would be correct. Okay, similar question again. So estimate the value of square root of 125 to 2 decimal places. So again, square root of 125 is between square root of 121 and square root of 144. Square root of 121 is 11 and square root of 144 is 12. If we look here, which one is 125 closer to, if we look at 121 and 144, we can see that it's closer to this side than the right hand side. So that means that our number is going to be roughly closer to the 11 side than the 12 side. So using that judgment, we can say that, okay, we can estimate that our estimate for this is going to be roughly 11.2. Yeah, or you can say 11.1. Either or, you would get the marks for that.